LightSpace explores a variety of interactions and computational strategies related to interactive displays in the space they inhabit, touching on aspects of multi-touch interactive displays, augmented reality, and smart rooms. LightSpace uses 3 PrimeSense depth-sensing cameras and 3 standard projectors. These are arranged to cover most of an office-sized space and are precisely calibrated to real-world coordinates of the room. This results in a fairly complete 3D mesh model of the room and its contents, complete with moving users. Because the projectors are calibrated to the same real-world coordinate system as the cameras, it is straightforward to project graphics of the correct size onto any surface visible to at least one camera and one projector. Furthermore, experiences are authored in real 3D coordinates without regard to which camera or projector is ultimately used. We use this basic infrastructure to explore a number of interactions on, above, and between interactive surfaces placed in the room. First, the user may view and manipulate virtual objects on this tabletop, which is just a regular desk. Also, there is a wall display that functions similarly. Here, the surface is just a piece of foam core. Beyond simulating the behavior of interactive displays such as Surface, we consider interactions that involve the space between surfaces. For example, our user can move an object from one surface to another by touching the object and the destination surface in that order. An object may also be picked up by sweeping it into the hand. The object is depicted as a sphere that can be held and rolled in the hands and arms. The object may be dropped on this piece of cardboard and handed from one person to another. The held object can be dropped directly on an interactive surface. It may also be placed on an interactive surface by touching the destination with one hand while holding the object in the other. We have also implemented a menu that is organized in space. The spatial menu is invoked by holding a hand in the column of space directly over the menu graphic on the floor. Menu selection changes as the hand is moved up and down in this column. Note that the text of the menu is oriented toward the user for easier reading. A menu item may be selected by pausing briefly at the selection. Finally, we show how LightSpace can highlight each user with different colors. When 2 people touch, they are considered the same object and are now the same color, and can even participate in the same interaction. We next detail how these interactions are implemented. Each depth camera returns a depth map where each pixel value indicates depth to the nearest visible surface. Each pixel can be converted to a real-world coordinate value and the entire image into a 3D mesh. Camera calibration gives the position and orientation necessary to place all 3 cameras into the same world model. The 3D mesh model from the depth cameras shows the detailed shape of the objects in the environment, albeit with some noise, and allows us to think in natural units of measure, such as millimeters. We segment static objects such as walls, tables, and floor from the user. This is accomplished by a simple pixel-wise depth comparison against a snapshot of the room taken without the user. The mesh model is used directly in calculating the behavior of the ball representing a picked-up object. The mesh model is also used in implementing the space menu. However, we have found it useful to project the 3D mesh data to an image rather than perform calculations directly on the mesh. This projection mimics that of an imaginary camera. This virtual camera view above the tabletop allows a simple emulation of image-based interactive displays such as Microsoft Surface. The wall display is implemented similarly. Meanwhile, an orthographic projection of the entire space generates a plan view of the room. This is useful, for example, in relating objects in the tabletop projection to objects in the wall projection. The system detects the user touching the tabletop and the wall displays simultaneously by finding an object on the tabletop and an object on the wall are physically connected to one or more of the same objects in the plan view. The transfer of a held object to the wall is accomplished in a similar fashion. LightSpace has only scratched the surface of interactions made possible by the combination of depth cameras and projectors.